continue our chapter 10. Chapter 10 is conic section. In this section, we're going to look at the plane that cut the cone. The first one, you have a cone and the plane cut it perpendicular to the cone. So the cut will turn out to be a circle. So if you look at the definition of a circle, if you have a point on the circumference, as this point traveling around the circumference, the distance from the point to the center, in this case called the fixed point, is always going to be the same. And the formula is x minus h quantity square plus y minus k quantity square equal to r square, where h and k is the center and r is the radius. The next one, you have a plane that cut the cone on the angle, and then the cut will have a shape of an ellipse. So you're gonna have either the vertical ellipse or horizontal ellipse. The definition of the ellipse is if you have a point and this point is traveling on the plane, the sum of the distance from this point to the focus point, we call is for F1 and F2, the sum of the distance between these two will always be the same. Now let's look at the formula a little bit. The formula is almost identical. My A is always going to be bigger than B and bigger than C. So if A is with the Y, you're going to have a vertical ellipse. If A is with the X, you're going to have horizontal ellipse. And C squared will always equal to A squared minus B squared. And we will go in more example for this picture later. All right. The third one, if you have a plane that cut a cone parallel to the side of the cone, you will have parabola. So parabola, it can be open upward, downward, to the right or to the left. For my example here, the parabola is open to the right. So the definition of parabola is if you have a point and this point is travel on this line here or a plane. The distance from the point to a vertical line, or this is called Directrix, and the distance from this point to the focus, which is inside the parabola, will always be the same. It doesn't matter if the P traveling in any direction on the plane here. So the next one, if you have a plane that cut, we have two cones here, almost vertical or vertical to the cone, you're gonna have a hyperbola. This example is hyperbola open up and down. You also can have the case that hyperbola open to the left and to the right. So the definition of the hyperbola here is if you have a point and as the point is travel, the distance from this point to focus point, the focus is the one here and here inside the two hyperbola. The difference between these 2 points, the distance between P to F2 and P to F1 is always going to be the same. So let's look at more examples. Okay, let's look at example of the parabola with vertex HK and A. A here is the distance from the plane to the focus, which is equal from the distance from the plane to the directrix. All right, and A is a positive. So let's look at the first one. The first one here is open to the right, and the vertex is HK. So the directrix is the vertical line to the left. And the formula is going to be y minus k squared equal to 4 times A times parenthesis x minus h. So the directrix, now we need to find the equation of directrix. Directrix is the vertical line. So the vertical line, you're going to have x equal to something. Now the distance from here to here is an A. Now the directrix is to the left. So it's going to be the change of x, which is h, which is going to be h minus A, because HK is over here, but you go to the left. So it's going to be h minus a. All right. Now the focus is to the right of the vertex. So the y coordinate is the same, which is k. The y coordinate is the same of the vertex, but the x coordinate, if this is h and the distance from here to here is a, is going to be h plus a will be your x coordinate, and that is the y coordinate for the focus, right? Now let's say if it's open to the left, the formula will be y minus k squared equal, it's going to be negative instead of positive if it's open to the left, x minus h. Now the directrix is the vertical line to the right, and the vertical line you're going to have x equal to something. The distance here is a and the distance here is a. So x going to be, the vertex again is hk. It's going to be h plus a because the distance here is a. So the vertex is hk. So it's going to be h plus a. Right? Now the focus is to the left of the vertex. The y coordinate will be the same, right? The y coordinate will be the same, which is k. Now the x coordinate, because it's go to the left, this is h, go to the left, will be h minus a, right? Now let's look at the next one. It's open upward. Vertex is hk again. The focus will be inside or above the vertex. The directrix will be the equation of y. Equation will be x minus h quantity square equal to 4a y minus k. Now if we want to find the directrix, which is a horizontal, it's going to be y is changing. Right here is k. So it's going to be k, but it's going down. So it's going to be k minus a, right? Because here is a, but it's going down. Now the focus is above the vertex. The x coordinate is going to remain the same, which is h. Now the y coordinate is going to be above, so it's going to be k plus a. All right, because k is over here, so k plus a. Let's look at its open downward. Vertex is hk. The formula will be x minus h quantity square equal minus 4a y minus k. Directrix again is going to be horizontal line, and it's going to be y equal to something. So hk is over here. However, the directrix, if this is a, this is also a. It's going to be k plus a because it's going up. Now the focus going to be below the vertex inside the parabola. The x coordinate is going to remain the same, which is h. The k coordinate, which is y, if it's hk here, is going to go down. So it's going to be k minus a. Alright, just try to understand how the picture and where is the coordinate going to go. Now let's look at, the length of latest rectum is 4a. So basically it's the distance from here to here when it go to the focus, right? Now let's look at the example. Given vertex is -1, 0, focus is -3, 0. They want us to find directrix and equation and graph. So first we're gonna graph what we have first, right? So let's look at the graph for what the given condition. So the vertex is -1, 0. So -1, 0 is over here. So this is the vertex. Now the focus is to the left, which is -3, 0. So the only logical is the parabola will be open to the left. It has to, because the focus is to the left of the vertex. All right, so look at the graph. The distance here should be A. So I need to find the directrix. So one way of looking at the distance here is A, which is 2, because -3 and -1, the distance is 2. So A is equal to 2. So if I want to find the directrix, it should be 2 units from the vertex. So 1, 2. So the directrix should be a vertical line here. X. So from -1 to 0 to here, x should be 1. Now because it's open to the left, you're going to have y minus k quantity square equal -4a x minus h. Vertex is -1, 0, which means h is -1 and k is 0. So I'm going to have y minus 0 square equal -4. My a is 2. X minus h. H is -1, so it's going to be +1. So y square equal -8 times x plus 1. All right. If the number here is not a whole number, you have to think that h vertex, h is -1 and k is 0 from here, hk. If the number is not perfect whole number, you have to use some calculation. So the focus is going to be h minus a and k. Then you have to use an equation. H here is -1 minus a is equal to -3, because focus is -3. And then solve for a. In this case, you're going to get 2. Either way. But I'm just counting because I can count. If I cannot count, then you have to use solve of linear equation. All right.